Hello everyone. Today we'll start Hill Cipher. So when we are going to consider Hill Cipher here, we are going to multiply plain text with the key matrix, and the key matrix is a square matrix. So it can be of dimension 2 cross 2, 3 cross 3, 4 cross 4 like this. The dimension can be increased. First, let us consider an example where the key matrix is a 2 cross 2 matrix. And every plain text is represented, the letter in every plain text is represented by its corresponding number. We know that we will be giving numbers from alphabet A to Z through the number 1 to 25, like 0 to 25, as I mentioned here. Now, before that, we are forming the encryption. In the decryption process, what we have to observe is, in order to get back the plain text, we have to find out the inverse of a matrix. So whenever we are going to consider any matrix as a key matrix, we have to check whether its inverse exists or not. So if the inverse of a matrix is not existing, it indicates that it cannot be a key matrix. Okay. So first let us consider how to find inverse of a matrix. So whenever we are going to consider inverse of a matrix, we can represent or we can find out inverse of a matrix by using the formula, that is adjoint of the given matrix divided by determinant of the given matrix. And in the calculator, we can able to find out the determinant. So using the matrix operation, we can able to find the determinant of A. So here, since this is a simple 2 cross 2 matrix, I'll just mention determinant of A as 5 into 3 minus 8 into 17. And whatever the operation we have to do, we have to take modulo 26. Why we need to take modulo 26 means we are having only 26 characters in the alphabet. And the numbering what we have given is between 0 to 25. If any value which is out of the range between 0 to 25, then we have to take modulus and bring them back within the range 0 to 25. So that is the reason we have to take modulus. So when we find determinant of A, we are going to get the value as minus 121 mod 26. Okay, this minus 121 is not in the range 0 to 25. What we have to do is we have to bring to the range 0 to 25 means, first let us consider the number line. In this number line, 26 is on right hand side from 0, that is origin. But minus 21, it is somewhere on the left hand side of 0. So in order to bring this toward in the range 0 to 25, what we have to do means we have to add positive values for minus 21. So when we are adding positive values, the number will move towards 0. But when we are going to add negative value, it will going to move away from 0. So one way of finding the modulus of minus 21 to minus 21 mod 26 is adding 26 for minus 21. How many times we have to add? When we are going to perform the addition, that is minus 121 plus 26. So when we are going to do this, what we are going to get? The value So when we are going to consider minus 21, when we are going to consider the value minus 21 plus 26, we are going to get the number as 95. Okay, it is minus 95. And when we are going to add, again, since 95 is not in the range 0 to 25, so once again we have to consider minus 95 plus 26. So once again, if we add, we are going to get the value as minus 69. And similarly, once again, we have to add 26 for minus 69. So we will be getting the value as minus 41. Sorry, minus 43. And for this minus 43, if we add 26, we are going to get the value as minus 17. And again for this minus 17, if we are adding 26, then the value will be 9. Now this value is in the range 0 to 26. Oh, sorry, 0 to 25. So we can consider minus 21 mod 26 is 9. Okay. See, if the number is small, we can able to add 26 for that number, and we can find out how many times we have added. We have added 6 times, isn't, sorry, 5 times. So when we add 25 5 times for 120, when we add 26 5 times for minus 121, we are going to get the value in the range 0 to 26. Suppose if the number is large, in that case, how we have to find out? So for that, the another method what we are considering is, we have to divide the number for which we want to find out the modulus. You divide this number from 26. So when we are going to divide this number from 26, here to 26 fours, it is 104. You forget about the sign, later we can consider the sign. So 121 minus 104 is 70. Okay. And after getting the remainder, which is less than 26, now you consider the sign. The sign of the remainder must be same as the sign of the number for which we are finding the modulo. So here the number for which I am finding the modulo is 121, and the sign of 121 is minus. So I need to consider this as minus 17. Since I have obtained the remainder as minus 17, then how I can consider minus 17 mod 26? The simple way is, we are going to subtract 17 from 26, and the value what I am going to getting is 9. So this is also one way how we can able to find out the modulus when the number is large. Okay. So now here we have found out the value of determinant as A. And the next thing what I have to find out is adjoint of A. So how adjoint is defined? Adjoint of A is same as cofactor of A transpose. Okay. So first let us find out how to find the cofactor. So now let me consider the adjoint process. So here adjoint of A is equal to cofactor of A transpose. A is 5, 8, 17 and 3. So A transpose is 5, 17, 8 and 3. And the next thing is, we have to find out cofactor. So when we are going to find out cofactor, here sign matters. So we, in this matrix, we can observe that there are two rows. This is row number 1 and row number 2, and this is represented by the variable I. And we are having two columns, column 1 and column 2, which is represented by the variable j. So now we have to find out cofactor of every element. So here what I can observe is, if I want to find out cofactor of 5, then I need to skip the corresponding column and row, and the remaining column and row we have to consider. Okay, so here the remaining column and row means only one element is left out. Okay, so I'll going to take that element, and what should be the sign of that element. So for that, I need to multiply that element with minus 1 to the power of I plus j. Okay. And the next, I need to find out cofactor of 17. Cofactor of 17 is again minus 1 to the power of I plus j, and this is 70. So now, sorry, cofactor of 17 means I need to skip the corresponding row and column. So when I skip the corresponding row and column, the only element left out is 8. So I'll going to take 8. And similarly, when I consider the cofactor of 8, again I need to take minus 1 to the power of I plus j. Here I need to skip this column and row because 8 is present in this column as well as in this row. So the value is 17, and here minus 1 to the power of I plus j, and the corresponding value is 5. So now we know that for the first row and first column, here I is 1, j is 1, and in this case I is 1, j is 2. Here I is 2 and j is 1, and in this case I and j both are 2. So according to that, minus 1 to the power of 1 plus 1 square. So minus 1 square is nothing but plus 1. So we are going to get plus sign for this. And here minus 1 to the power of I plus j. So 1 plus 2 is 3. So minus 1 cube is nothing but minus 1. So minus 1 into 8 is minus 8. Similarly here minus 1 to the power of 3. So we are going to get minus 17. And here minus 1 to the power of 2 plus 2, that is 4. So we are going to get plus 5. So this is the corresponding cofactor. And since the number minus 8 and minus 17 are not in the range of 0 to 25, we need to take mod 26. So how we will going to get mod 26? You just subtract this number or add 26 for minus 17. So when we are going to add 26 for minus 17, what we are going to get? We are going to get the value 9, because 26 minus 17 is 9. And similarly, when we are going to add 26 for 8 minus 8, we are going to get the number as 18. So this is the corresponding cofactor. So for this cofactor, what I have to do? I need to multiply. In order to get A inverse, we have to consider adjoint of A by determinant of A, or it is equivalent to cofactor of A transpose by determinant of A. Okay, so accordingly, here what I need to do is I need to take multiplicative inverse of A determinant, and that I need to multiply with the cofactor matrix, that is nothing but 3, 18, 9 and 5. Okay, so how to find multiplicative inverse? Again, we know that Euclidean algorithm, that is A1, A2, A3, and then I need to take B1, B2, B3, and then R1, R2, R3, and finally Q. Okay, so when we are going to consider this, we can observe that while taking multiplicative inverse, A1 and A2 must be initialized to 1 and 0, and the modulo is 26, and here B1 and B2 must be initialized to 0 and 1, and the corresponding modulo is for which I need to take inverse, the multiplicative inverse of 9. Determinant of A is 9. So I need to take multiplicative inverse of 9. So I'm going to take 9 here. And now first I need to find out the quotient. Quotient is nothing but A3 divided by B3 and its integer part. So when I'm going to do 26 divided by 9. So what we are going to get? Quotient is 2. Okay. We are going to get so here the remainder, the quotient what we are going to get with respect to 26 by 9 is 2 and the remainder what we are going to get is 8. So according to that, here what we are going to do, we are going to write the remainder R3 as 2 and the quotient, remainder R3 as 8 and the quotient as 2. So now we have to find out the remainder R1 and R2. So here R1 is nothing but A1 minus B1 into Q. So A1 is 1 and B1 is 0. So the R1 is 1 and R2 is nothing but A2 minus B2 into Q. So here B2 is 1 and A2 is 0. So we are going to get the value as minus 2. And now since the remainder is not equal to 1, we have to repeat the process. So when we are going to repeat the process, here the next larger number will become the value which is in the column of B and the smaller number will become the value which is in the remainders. So according to that, we are going to get A1, A2, A3 as 0, 1, 9. And then we are going to get the remainders as 0, 1, 9 and here we are going to get the remainders as B, that is 1, minus 2 and 8. So now once again we have to repeat the process. So 9 divided by 8 means we are going to get quotient as 1 and remainder as 1 and we have to see the remainders R1 and R2. So R1 is nothing but A1 minus B1 into Q. So here A1 is 0, B1 is 1. So we are going to get the value as 0 minus 1. So the value is 1. So now how to calculate R2? R2 is nothing but A2 minus B2. So here A2 is 1 and B2 into Q. So here B2 is minus 2. So 1 minus of minus 2, we are going to get the value as 3. Since the remainder R3 is 1, the multiplicative inverse of 9 will be R2. So here we are going to get multiplicative inverse of 9 as 3. This is one way of finding the inverse. The other way what we can do is, we know that when we are going to multiply two numbers and take modulo, if the value is equal to 1, the modulus is equal to 1, then the corresponding number which we have multiplied will be the inverse of the other. So here let me observe that method also. So when we are going to multiply 9 with 2 and take mod 26. So what we are going to get? The modulus value is 18 only. So 18, we should get modulus equal to 1. Since it is not equal to 1, 2 cannot be the inverse of 9. And if I multiply 9 with 3 and take mod 26. So here 9 into 3 is 27. 27 mod 26 is 1. So this indicates that 3 is the multiplicative inverse of 9. This is also one way of finding multiplicative inverse. If the number, that is the modulo, is small, you can find out by this method. After multiplying, which value is we are going to get modulo as 1. So if this condition is satisfied, directly we can take this as inverse. Suppose if the number is large, in that case we have to follow extended Euclidean algorithm. Both will going to give the same result. So now, according to this, for getting the inverse, what I have to do? I need to multiply multiplicative inverse of determinant of A with the matrix 3, 18, 9 and 5. Okay, so now I'll just write the result here. 3 into 3 is 9 and 3 into 18. So what we are going to get? We are going to get 54. And next 9 into 3 is 27 and 3 into 5 is 15. So here we can observe that two values are in the range, two values are in the range 0 to 25 and other two are not in that range. So for that we have to take mod 26. So when we are going to take mod 26, we are going to get 54 mod 26 is 2 and 27 mod 26 is 1. So as a result, this will be the inverse. This is how we can able to find out the inverse of a given matrix. And one thing we have to remember, we can able to get cofactor of a matrix, but if any number is not having multiplicative inverse, then we cannot find out inverse of the matrix, because we have to multiply multiplicative inverse of determinant of A with the cofactor. Suppose how we will come to know whether the number is not having multiplicative inverse? So in that case, in the extended Euclidean algorithm, we can easily find out. So here, if we do not get the remainder 1, instead of 1, if the least remainder what we are going to get is 0, that indicates that the number is not having the inverse. Okay. So instead of getting 1, if we are getting the least remainder as 0, we can easily tell that the matrix A cannot have an inverse. If we are getting the remainder 1, least remainder as 1, then we can tell that the matrix is having a inverse. So first, to check whether the matrix is having a inverse or not, what we have to do? We have to check whether multiplicative inverse of the determinant exists or not. If it exists, then try to find out the cofactor. If it does not exist, then no need to continue further. This is how we will going to find out inverse. So till now we have discussed how to how to find out multiplicative inverse of a matrix. So next, let us consider how to encrypt the message. Okay. So let me copy the data from the first slide. So here the message what we are having is pay more money, and the matrix what we are having is A. So now I'll just consider the corresponding matrix. Here we are having plain text as pay more money. And now I need to express this in terms of number. Okay. So in order to express this in terms of number, we know that we are going to use the numbers which we have considered in the first slide, that is 0 to 25. So according to this, the numbers for P is 15 and the number for A is 0, for Y it is 24, and for M it is 12, and for O it is 14, and for R it is 17. I'll just write down as a matrix itself. Okay, because I need to multiply P with K. So here, sorry, P with A. So here we are having A as 2 cross 2 matrix. So what I am going to do means I'll going to express this as a matrix with only 2 columns. So why we have to consider 2 columns? The number of rows in the number of columns in matrix 1 and number of rows in matrix 2 must be same. Then only we can able to perform matrix multiplication. So now I'll just write this as P A Y M O R E M O N E Y. And here the matrix what I'm having is 5, 8, 17 and 3. And this is the key matrix and this is the plain text matrix. So now I need to express these letters in terms of number. So the number for P is 15, A is 0, Y is 24, M is 12, and O is 14, R is 17, again O is, E is 4, M is 12, O is 14, N is 13, E is 4, Y is 24. Okay, this is the matrix we are going to get. And now I need to consider 5, 8, 17, 3. These matrices I want to multiply. So now we know that a large matrix can be divided into small matrix. And in the calculator, we can able to use the dimension 2 cross 2. So here, since key matrix is 2 cross 2 matrix, here also what I'm going to do means I'll just divide this large matrix as 3 submatrix. So the first submatrix is this, and the second submatrix is this, and the third submatrix is this. And then what I am going to do, I'll just multiply the first submatrix with key, and I'm going to get the corresponding answer as 75 and 120. So here the value is here. So in this case, we are going to get the value as 120, and we are going to get this value as 324, and this value as 228. Direct matrix multiplication. So here you take one submatrix as A in the calculator and the key matrix as B, and then you perform matrix multiplication. So when we perform matrix multiplication, directly we will going to get all the 4 values. And the next, again you take second submatrix, and in this second submatrix you multiply the submatrix A 14, 17, 4, 12 with 5, 8, 17, 3. So what we are going to get here? Here we are going to get the values as 359 and then 163, and we are going to get 224, and another value is 68. So this is another matrix multiplication. Now you multiply the third matrix with the corresponding key matrix. So we are going to get the third matrix as 291, and then it is 151, and next the value is 428, and then we are going to get 104. So using calculator matrix multiplication, we have done the multiplication. And since the values are out of range, so what we have to do? We have to take mod 26. So when we take mod 26, we will be getting the result. So we will be getting the result as 75 mod 26 is 23, and 120 mod 26 is 16, and 324 mod 26 is 12, and this value is 20, and next we are going to get 21 and 7, here it is 16, this is also 16, and then 5, 21, then 12, and then 0. Okay, this is how we are going to get the corresponding ciphertext matrix. Now you find out the corresponding letters. So 23 means it is a letter X, and for 16 it is Q, 12 means M, 20 means it is U, and 21 is V, 7 is H, and 16 is Q, and 5 is F, and again 21 is V, 12 is M, 0 is A. So the corresponding ciphertext, what we are going to get is the ciphertext C will be equal to X, Q, M, U. Row by row we have to write X, Q, M, U, V, H, Q, Q, F, V, M, A. This will be the ciphertext for the plain text, pay more money. Then how to get back the plain text from the ciphertext? Again, we have to consider the product C into A inverse. Okay, so here the corresponding ciphertext matrix I'll just write, that is 23, 16, 12, 20, 21, 7, 16, 16, 5, 21, 12, and 0. Okay, this is the ciphertext matrix we are having. Again, divide this ciphertext into 3 submatrix. Okay, and separately you multiply submatrix with the corresponding key matrix. So here A inverse, what we found out was 9, 2, 1, and 15. So now you perform this multiplication. So when I multiply the first submatrix with the key, that is K inverse, we are going to get that submatrix as 223, and then 286, and 128, and 324. This is first submatrix, and the second submatrix what we are going to get is second submatrix into A inverse. We are going to get the values as 196, 147, and then 160, and then 272. This is second submatrix, and after multiplying with the third submatrix, we are going to get the result as 66 and 325, then 108 and 24. Okay, since the values are out of the range, we have to take mod 26. Now when I take mod 26, what is the resulting matrix I am going to get? So here I am going to get the resulting matrix as 15, 0, 24, 12, 14, 17, and 4, 12, 14, 13, 4, and 24. Okay. So this is the same plain text matrix what we have considered here. So both are same. That indicates that we can able to get back the cipher text. Okay. This is how we are going to consider Hill cipher.